Hi, and welcome to this week's class on 3D Pythagoras and Trigonometry. This forms part of my session preparing those in Year 10 for their GCSEs next year. So it covers a lot of the big topics in Maths GCSE and gives you a bit more practice and a few explanations for some of the trickier ones. We're looking at 3D Pythagoras and Trigonometry today, which is one of those topics that a lot of people find really tricky. I'm going to try and break it down and give you some little tips on how to visualise those triangles in the 3D shapes, as I think the actual trigonometry people can do, it's just finding the right triangles. It's kind of from my experience of where people tend to slip up. So before we start, if you can just have a little look at these diagrams and see if you could label a base, a face, a plane, an angular elevation, and so on. There will be multiple options or multiple correct answers for these, but I just want you thinking whether you know all of that terminology. Okay, I'm just going to give you 1 minute or so. I would recommend printing them out before the session next time, so you can have a bit longer to do the starter and really make sure you get it. But I'll give you 1 minute while people are logging on. As always, if you've got any questions during the session, please just type them in the comments box or the chat box to the right, and I'll get back to you alongside it as soon as I can. Okay, finish the one you're labelling, or have a little look down towards the end of the list and just check mentally in your head whether you could label those terms on the 3D shapes. Right, should we see what we've got? Okay, so firstly, a base, we could have ILKJ or ABCD. Now, get used to this way of labelling things. IJKL, hopefully you can see, is the square base of the pyramid. You could have written those in any order. It has to sort of follow either clockwise or anti-clockwise. So for example, I could have had ILKJ or IJKL, starting from I. You could start from L and go clockwise or anti-clockwise, but you wouldn't normally go I, then K, then J, then L. So see what I'm doing there, skipping across. So it's just labelling convention. An example of a face could be JNK or AEFB on the cuboid down the bottom. The base is also a face, so that it could have been the base as well. But again, labelling them in either a clockwise or anti-clockwise way. Now a plane, this often trips people up. I've given you an example here. In the cuboid, we could have EHBC. Now can you picture that? I'm going to try and draw that one on for you. E to H and then BC. So I probably should have written EHCB actually, following it around. So C and then to B. So it's like a diagonal cut. Imagine that's a cake and you've taken with a knife a cut from the top left to the bottom right and you've sliced it all along. So that plane is the whole of that rectangle in 3D space. Okay, so it can slice an object through. They could be planes of symmetry. This one's not in a cuboid. There are other planes of symmetry, but that one is not actually identical in a cuboid. The next one, you've got JNL as well. If you look in our square-based pyramid, JNL is that triangle that cuts the pyramid in half diagonally. So it's diagonally across the square at the base. I'll just draw that one in for you. That's sort of going like this and cutting it just through the middle. So each person would have half of that. Okay, an angle of elevation. An example could be CAG. So that's if we look in our cuboid, can you see from going from C to A along the bottom there and then up to G, our angle would be that bit in the middle. So remember, if you're labelling angles, we use 3 figures and it's sort of the angle between CA and AG. So it's always at the letter in the middle, but the other two tell you what lines it's between. Or in the top one, we could have had MJN. So again, we draw a line from M to J and then J to N, and it's the angle between those two lines. So it would be that line. Okay, so angles of elevation are angles looking up from the bottom of an object to the top of the object. Cross section, an example could be AEFB. So that's just that first face really in my cuboid, cross section. You could do that anywhere down the shape. Or in that same one, I've gone for BFGC, the other face, and you could cross it in that way. Imagine you're slicing a cake for lots of people. Can't really get a cross section of a pyramid because everywhere you cut it, you will get a slightly different size piece or slice shape. If you think about sharing out a cake, it's not going to be fair if you just cut and cut. So it tends to only be with prisms like the cuboid or a triangular prism that you would use that. Vertex, so our vertex is N, that's the point at the top of a 3D shape. It could be E, F, H, G, C, B, A, D, J, K, L, I. They're all vertices. It's sort of the pointy bits on 3D shapes, and it's technically where edges meet. Okay, edges meet, but I've chosen one there, which is the highest one on the pyramid. The next one is angle NLM. Now NLM, again, draw it. N is at the top here, down to L, down to M. I think I've actually got that drawn on for you. There it is. NLM, and the angle between them. The slant edge, so we're getting into some slightly more specific terminology here. The slant edge could be IN. So let me change the pen colour. Can you see that's over here? So a slant edge is, the slant is only for things like pyramids where you've got those triangles that are sloping inwards. We don't have slant edges or heights on a cuboid. So slant edge is those edges of those triangular faces. The slant height, for example, would be ON. So let me just say the slant edge was that green one, and the slant height is ON, this one at the middle. So that's the middle of the slanted face. Okay, so slant height is up the middle of the face. Slant edge are those edges of our 3D shape. Now a face diagonal, we're not going to get a diagonal on the triangular faces of our pyramid. We could get a face diagonal on the bottom. Just clear those. Our face diagonal could be, for instance, J to L. So it's going diagonally across a face. We tend to use it more in cuboids. So for example, it could be B to G or B to E. So that's either across this face diagonally or across this face diagonally. It could also be across the top or the bottom diagonally, but that tends to be a face diagonal, so diagonally across a face. And then a space diagonal, an example is from A to G. That's actually the dotted one already drawn in on that cuboid. So from A to G, it's going through 3D space, from bottom left to top right. Or C to E, it could go from bottom right to top left. It could be D to F or B to H as well. So quite a few options for that. But you do need to be aware of this terminology. So slant edge, slant height, face diagonal, space diagonal. They're the sort of trickier ones. Okay, we'll be using them throughout the session, so hopefully they'll become more familiar. Let's get going then. So the key to 3D trigonometry and Pythagoras, you sort of have to do both normally, is spotting right angles. So you can see the square-based pyramid on the left, and that's showing you some of the right angles that there are. So just take a moment and have a look at that diagram and see if you can work out how that's being cut into those different right angles. Can we see that? Do you remember what name was given to this line here? What's that one? the slant height. Super. It's labelled over here as well. Slant height, or a fancy word for it, an apothem. I'm going to talk about face as well. That is one face, so that would be the face height, or the height of that sloping face. It mentions lateral edge. We called it the slant edge earlier. A lot of people call it slightly different things, but the key word is the edge part in there. It's the edge of those kind of straight lines that join faces together. We've got the height of the pyramid, so that's right down the middle. Can you see it's gone to the midpoint of the square base and a perpendicular height up? And then the angle that a lateral edge makes with a square base. So you can see we've got a lateral edge here, that diagonal. We've got the square base, and we're finding that angle between. I'll give you some tips for visualising things like that, because they do get a little bit tricky and harder to spot. Okay. Now let's go through some examples of questions. I'm going to give you one example and work through it, and then I'm going to give you a go to have you a chance to have a go. So let's look at the one on the left first. A, B, C, D, E, F, G, H is a cuboid. Work out the value of CAG to 1 decimal place. So first off, we've got to find out where angle CAG is. Now C to A is that line there. Then we need A to G, which is that line there. Okay, so you see for that angle C to A to G, so that means we're trying to find the angle between those lines. So look at that red triangle. Those two lines we had, CA and AG, have joined up with the sides GC to give us a right angle triangle. Now I know I have to find that angle, and I've got, if I just bring that triangle, actually I'm going to go back a second with that one. If we just look at this red triangle, I've got to find theta, my angle down the bottom there, and I know the height of that triangle is 4. But I don't know the base and I don't know the hypotenuse. So we need some more information. We can find the base of that red triangle though, because if you look at the blue triangle I've drawn on the bottom, can you all visualise that? Pretend you're looking over the cuboid directly down at it, like a bird's eye view. And on the ground you could see this blue triangle. We've got it drawn out separately here. So AB is 7 centimetres, BC is 5 centimetres, and then that diagonal AC is also the bottom of our red triangle. Now what technique would we use to find out what x would be? Super, Pythagoras. Okay, no angles involved with this one. We do the square root of 5 squared plus 7 squared and we get root 74. Now I'm going to leave it as root 74 because otherwise it's going to be a decimal with lots of places and I'm going to have to round, which is going to make my answer inaccurate. So leave it if you can as its raw form or as its third value there. Now I've got the base of my red triangle, so I'm going to draw that out separately. You see we've got theta, we've got 4 for the height, and I've got root 74. Now I can use trigonometry to find that angle. That's TOA. We're going to use tan to the minus 1 because we're finding an angle of the opposite, which is 4, over the adjacent, which was root 74. And it gives us an angle of 24.9 degrees. I'm not going to go into much detail about how we do the trigonometry on this session because I have covered that in previous videos. So if you're stuck at the trig section, then please go back and watch the trigonometry video first and then come back to this. I just wanted to point out, can you see how I'm labelling those triangles? I'm drawing them out separately to the shape. And this is really key. I'd be expecting you to do this on your exam papers or whenever you're doing practice questions like this. Draw out the separate triangles. It takes 3 seconds to draw a triangle out like that. And you see how I've labelled each corner with a letter? That's so you can really clearly see which triangle it was from the diagram. And I'd expect you to do that on your written work as well. Okay, you have a go then at the blue example. So I want you to try and work out where it's talking about, what it's talking about doing. So try and find that angle and try and split it up. I'm going to give you one clue in a minute. I'm going to give you a few seconds first to see if you can work it out. Then I'll show you the triangles drawn on the diagram and then let you work through it. Okay, have a go. Okay, little clue coming up if you need it. I'm going to go back through that in a minute, but there are the triangles. If you want to have a go and work it out, I'll then give you a little hint as to where they came from. Alright, 30 more seconds on that. Don't worry if you are struggling, I'm going to go through it. Okay, let's pause there wherever you're at, and we're going to go through it together and see if we get to the same answer. I'm just going to go back a few steps there. So the key difference in this question is it's saying work out the angle between the plane DCGH and the line HB. So we've got to try and draw those in first. Now our plane DCGH was that back face. Okay, that's a rectangular face at the back, DCGH. And the line HB, which is that line. So most people manage to sort out, we've got a plane, we've got a line, but then they struggle to work out where to draw in the triangle. Now I've got a hint which works for all questions like this in terms of planes. It does require you to visualise it in 3D a little bit, but it's shining a torch at that plane. So imagine this torch is coming right from the front of the cuboid and we're shining it at the plane. Where is the shadow of the line HB going to fall? So shining a torch through HB towards that back plane. Can you see the shadow is going to be there, H to C? Yeah, so right from the front that torch is shining it back onto the plane, and that line would cast a shadow H to C. Now where's your right angle triangle? Can we see we've got a right angle at C? Yeah, that's because we've got a face. HC is a face diagonal, so it's just on the back there, and then it's coming towards the front along the line CB, so that's perpendicular. HB is our space diagonals going back. So then we've got our triangle, and again we know the same information as we did in the example. We've got 6 and we've got the angle that we're trying to find out, but we need to find the other length. So therefore we're going to use this triangle here. Look at the top of the diagram, the triangle HGC. Can you see I've copied that out? We've got length 10 and 8. Use Pythagoras to find x, which gives us 2 root 41. Then draw out your separate red triangle. We should have a length along the top of 2 root 41. If you wanted that as a decimal, just to check your own answer, one moment, we get 12.8 or thereabouts. Okay, 12.806 for that length. Remember, keep it as long as possible because you never want to round during a question. Then use trigonometry. This time it is still tan. We've got O and A. We're trying to find angle, so inverse tan of the opposite, which is 6 over the adjacent 2 root 41, and we get 25.1 degrees. All right, I hope you got that. Using that torch, shining a light towards the plane, works in all of these types of questions if you're really struggling to find that triangle. We're going to do a few more examples all together, and then I'm going to do some quick fire questions where you're just practicing spotting the triangles. So stay tuned and keep working at it, and hopefully you'll feel a bit more confident at the end. Okay, let's show one more example. We're going to move on to a pyramid. Hopefully. There we go. So this pyramid ABCDE is a square-based pyramid. E is the apex of the pyramid, so that's right at the top there, directly above the centre of the square base with length 2 centimetres. Oh, sorry, ignore that 2 centimetres bit. I think that's a mistake because the square base has length 4 centimetres. Sorry about that typo. M is the midpoint of AC. So AB equals 4 centimetres, EC equals 6 centimetres. So everything is correct on the diagram now. Calculate angle MAE to 1 decimal place. So first off, we draw in that line to find that angle MA and then A to E. Now can you see that's my yellow triangle that I've drawn, M to A and A to E. So that is the angle we're trying to find. We don't have enough information to find that, so we need to use our blue triangle as well. So on the base, we've just gone diagonally across the base of our pyramid, and we've got this triangle, ACB. Now we know it's square base, so we've got 4 and a 4. We can find that whole length, AC, by using Pythagoras. We get 4 root 2. Now that's the whole diagonal across, but can you see we only want half of it because we only want to go to the middle of our pyramid. So we actually only want 2 root 2. So just make sure we're halving it. That's because when we originally drew on that triangle, we wanted angle MAE. And can you see we're just using that half point of the pyramid. Now draw out your yellow triangle, and we should have our 2 root 2 along the bottom. We've got theta and we've got 6. We're given that EC is 6, and because it's a square-based pyramid, all of those edges along that way, that orientation would be 6. So now we can use trigonometry, and we're going to be using cos this time, as we've got an adjacent and a hypotenuse. Finding the angle, so use cos to the minus 1 of 2 root 2 over 6, and we get 61.9 degrees. All right, so it's just remembering to halve a length if we need to with that one. Right, you've got a similar question. Just be careful with what angle you're finding. Okay, be careful drawing that one on. Again, I'll put up the diagram with the triangles, but I'm going to give you 30 seconds or so to see if you can work it out for yourself first. Off you go. Alright, little hint coming up. Those are your triangles that you need. Draw them out separately and try and work out your angle. Right, 30 more seconds. Hopefully we're on our trigonometry triangle now. Okay, let's have a look together. So our first triangle we needed was the base because we needed to find the length A to C. So we've got 2 and 2 with our square-based pyramid. Use Pythagoras and we get 2 root 2 for that whole diagonal. Now I'm going to halve it because I'm going to use half of this triangle as my next move. Okay, so it's a little right angle in there. So I'm halving that, so I've now got a right-angled triangle. Now, that means my base is just root 2. I've got a slant height or slant edge there of 3, and I'm trying to find the angle at the top of theta. If I use trigonometry to do that, I'm going to use sine because I've got my opposite and my hypotenuse. I get 28.12, but I'm going to double it to get my final answer because we actually wanted AEC, not just the middle. We wanted the whole bit. So times your angle by 2 and you should get a final answer of 56.3 degrees. Okay? Now you didn't need to halve it. You could have done it with that whole triangle. So I've used the triangle here, AEC, to show you how it could be. The whole base is 2 root 2, both sides are 3, and we're trying to find theta. Now, is that a right angled triangle? No. But can you spot what rule I could use to find theta? Thinking back to one of my other sessions. You got it? It's the cosine rule. Well done. So you can either use it in whichever form, length form or angle form. This is it rearranged to find an angle. Cos A equals b squared plus c squared minus a squared over 2bc. And your angle would come out as 56.3 degrees. You wouldn't double it this time because you're originally finding that whole angle, not just half of it. Look back on my lesson on sine and cosine rules if you need a little recap of how to do that and how to label your shape. Okay, I hope you managed that and it's getting a bit clearer. What we're going to do now is a few quick questions just to practice spotting those triangles. So, before we do that, I'm going to actually give you a little hint on how to do this if you're really struggling. It might be that you just can't picture them in 2D like this from these diagrams, and I think it's quite hard unless you've seen it in 3D. So if I was teaching this in the classroom, I tend to get physical 3D cuboids, and we use ribbons or pipe cleaners to draw on those 3D triangles, and it makes it a lot easier to see. And you don't have to do it for every time you do a question like that, but it means that if you've done it once, you can visualise much clearer what to do. Now, I tried doing this at home using my son's pipe cleaners, so I'm going to show you a way that you could do it if you've got any of these lying around, any pipe cleaners, because they hold their shape quite nicely. They're quite good. So you'll need 4 pipe cleaners. Bend them like this, so that's a 5 centimetre, 5 centimetre, 10 centimetres, 5 centimetre, 5 centimetre. Then put 2 pairs together like so. So I've twisted them on. These little bits are just going to be for twisting along a side to make it stick. Okay, so that's why they're there. But you should be able to make 2 lots of these coming off at that angle. Once you've got 2 of those, combine them and you should have your cuboid. Okay, at least your kind of skeleton structure of it. If it's not working, just try and rotate a piece and see if you can get it. It doesn't need to be exact. Remember, it's just to help you visualise it. Once you've got your cuboid, you can start adding in your triangles. So take a different coloured pipe cleaner, and I'm trying to copy this example at the top here. I'm doing that blue triangle on the base of it. So if you can see, the top angle is a bird's eye view. So looking at it from above, you can see that blue triangle. And this one is looking at it from the side, sort of like the diagram was, the blue triangle. Then let's add in our red triangle, and that's going up from point A to point G and down on top of the blue triangle. So can you see both the blue and the red share this line at the bottom there? They share that same line. Okay, so do try that at home if you want, and it might just help you visualise these 3D shapes a bit more. Choose a diagram and see if you can copy it out. And I think once you've done it once or twice, you get to see where those triangles are. Because there's not that many triangles you could have in a cuboid. Okay, once you've done a few practice questions, you'll have covered them all. All right, let's do our quick quiz now and see if this helps. So this is about spotting the triangles. I've got a few hints for you on the right. So you need to draw new lines onto the diagram to create the right angled triangle that will help you answer the question. Now I only want one triangle. So if you look back at our previous question, we had the red triangle and the blue one. We're only interested in this red triangle, so the main triangle that's got the angle we want in it. Yes, we had to use the blue one as well as our first step, but I'm not interested in that one for now. Just the main triangle that we'd need to find our angle. And remember the torch. It may be helpful to imagine you are shining a light towards the plane and look for the line's shadows. So that's only really if the question is asking you about a plane, a line at a plane. And remember, I'm not asking you to answer the question. You don't have to do any trigonometry. It may even be impossible in some of these questions because we're just spotting the triangles, okay? I haven't checked the information they've given you is enough to actually answer it. So let's have a look at this one together and then you can do one. Find the angle AHF. So do you remember how to draw that triangle? A to H, then H to F. That should be our triangle. And mark on the angle. Can you see at the bottom there? Angle H there. AHF is the one we're trying to find. Super. That's it. That's all we're doing. Marking on the first triangle, moving on. Next question. What triangle would we need for angle FCH? Oh, I would note as well, these are on the handouts that were downloadable on the website. So if you're watching after the session and you can pause it, it'd be really handy to pause it here and print off that sheet. I've put all these questions on one sheet so you can just work along it with me and practice drawing in those triangles. Okay, if you want to pause it after the session and have a go just to test your memory and check with the video that you're correct, then I'd recommend that. So angle FCH, that would be our triangle. F down to C, C up to H, and then join H back to F. And you've got your nice right angle triangle. Find the angle RMP. So R to M, M to P, P back to R. And we've got that one. This one's actually just on a face. It's not in 3D at all. It's just on that rectangular face. Next one, angle PRT. Can you draw the triangle in that you'll need and work out where the angle is? Let's check. Super. So even though it says P to R to T, we would only need to use that half a triangle to work out the angle. It would be the same as M to R to T. Next one. Find the angle EAC. Then they're going to start getting a bit more challenging in a minute. E to A to C. Have a look. Lovely. So again, we only needed to go to the middle. You could have gone to C, but then we'd have ended up with not a right angled triangle if you'd gone EAC and back to E. So we're looking for right angled triangles. Find the length of the line FD. So this is getting slightly trickier here. We may need to think of using our torch. Okay, so our line FD is there. It's a space diagonal. Now it doesn't say onto what plane. It just says find the length of it. So it doesn't matter what plane we point our torch towards. So I would just point it down from above and imagine the shadow. So where's the shadow of the line FD going to fall? Yes, it's going to fall between B and D. So we've got our line, we've got a shadow beneath it, and can you see that creates a nice right angle triangle? And we'd then use that to find the length of the line. You could have got your shadow line on any of the faces, it would have been fine. Okay, next one. Find the angle between the line AD and the plane BCDF. So remember, draw your line on and then point your torch towards that plane. Should we have a look? So that's your line AD. Shine a torch from above, because we're shining it onto the plane BCDF, which is the base, and your shadow would be there. So our triangle is ADB. All right, well done. Next one. Find the angle between the line TR and the plane TUSP. So be careful about which plane we're using here. Where are you going to shine the torch towards? Should we have a look? So the line TR is that one. We'll shine the torch towards TUSP, which is our back left plane. So the shadow will be there, T to S. Now we've got a right angle triangle with its right angle down at S there, RST. And the angle we're interested in is this little one here, STR. So it's always the angle between the line you found and its shadow. Okay, the line and its shadow. Next one. Find the angle between the space diagonal and the plane ABCD. Okay, so the space diagonal, again, you could have had a few different options for your space diagonal. It just has to go diagonally through the shape, okay, 3D space. Onto the plane ABCD, so shine a torch down onto that plane. Where's its shadow? Directly beneath it. We've got a nice right angle train there, the right angled triangle. Yours might look different if you chose a different space diagonal. You would actually get the exact same angle, whichever space diagonal you chose. All right, next one. Find the angle between the line FD and the plane ABCD. All right, should we have a look? So the line FD is there. Shine a torch towards the plane ABCD. Its shadow would lie there. We've got a nice right angle triangle. And we're trying to find the angle at the top there between BD and DF. Next one. Find the angle between the space diagonal and the face ABGF. Again, it doesn't matter which space diagonal you choose. So just start by drawing one in and work out where its shadow is going to be. Let's have a look. So I've chosen this one, H to A, and its shadow is going to be on the face ABGF. So this time it didn't say plane, it said face. Okay, absolutely fine. And it's going to be there. So I've got my triangle with a right angle down at G there, HGA. Super. I think one or two more of these. You're doing really well. Find the slant height of the face AVB. Can you remember what part that was? Find the slant height of the face AVB. Right, that was your slant height. Remember, it's a slant edge if it was on the edge of your face. Slant height, middle of your face. And your triangle would be across the left and down. It depends what information you've been given. You could do your triangle towards the middle and then up like that if you've been given that information. But for this specific question, can you see we've got the 10, so we know that this base is 5. We've got that one as 12. It's actually just a nice Pythagoras question. All in 2D there, but it's just slanted. Okay, well done on those. I really hope they've helped a little bit, and I would say remember that tip about the torch, shining it onto a face or a plane if you need to. Okay, remember you can always go back and watch these again and pause if needed. Now there's a few more practice questions here. I'm not going to pause and go through them with you during the session, but after the session, if you want some more practice, pause them and then check the answers. Okay, so pause it if you want to go. Answers are coming up now. Okay, pause if you need to mark your answers. Any questions, just put them in as a comment under the video and I'll get back to you. Next question. This one's tricky. It doesn't give you the diagram. You have to draw it out. That's a hint. Pause it. And answers. So that's a space diagonal and a face diagonal. Find your triangle. Use both trigonometry. And we've got it. I'll just go back if you didn't get a chance to mark that. Pause it if you need to mark. And next question. Pause to have a go at question 3. And answers are coming up. Pause to mark. And final one on this one. Question 4. Pause to have a go. Answers coming up. Pause to mark. Sorry, one more. Pause. Answers. Pause. And well done. Okay, so that's all there for you to practice if you need to. You can also find practice questions on Coolbit Maths 259 and 332 for 3D Pythagoras, and then 332 would combine Pythagoras and trigonometry. So it's more like the ones we've been doing today. Our next lesson will be on Wednesday, and it's going to be on inequalities. So we're going to be moving on from trigonometry, which feels like we've been doing it for months, onto inequalities. We've only got a few more sessions because I'm only going until the week before the end of term. So I'll let you know on Wednesday exactly what date that is, because I'm sure you all need a good break over the summer. But check my Facebook page and my website for handouts before the session. All right, see you Wednesday. Well done.